Hi, everybody. Thank you for joining us today. We have a very exciting webinar. In fact, we had over 300 people registered for this session, so this is very cool. We have many people actually joining us as we speak, so we are going to wait probably a couple of minutes and then we'll start. So don't go anywhere. We'll be back shortly. Hi again, everyone. Good morning, good afternoon, good evening, depending on where you are in the world. Thanks for joining us for this Gigaspaces webinar. My name is Noam. I run product marketing at Gigaspaces. And before I'm going to hand over the torch to Massimo for this session, just a few housekeeping items. But this webinar is recorded. The recording will be made available to you guys shortly after the session. The slides themselves, however, will not be shared. This session will be 1 hour long. We encourage you guys to ask questions during the session. We'll try to even take some questions during the session if we can, but certainly we'll have a few minutes dedicated at the end to answer any questions you may have. So to ask a question, if you want to ask Massimo a question about anything that was discussed in the session, simply use the Q&A box for Massimo questions. If you have any other issues, technical issues, audio, video, or any other question other than questions for Massimo, please use the chat box. So you have both of them, the chat and the Q&A boxes on the bottom strip. So with this out of the way, allow me to introduce Mr. Massimo Pezzini. Massimo has recently retired from Gartner, where he spent the past 25 years as a senior analyst. It was in this role where Massimo originally coined the term Digital Integration Hub, or DIH, which generated a lot of attention among IT leaders in enterprises anywhere. And of course, this will be the focus of today's session. So without further ado, I would like to pass the mic to Massimo. Massimo.
Thank you, Noam. Thank you, Noam, for the introduction, and good morning, good afternoon, good night, everybody, depending where you're calling from. Yes, my name is Massimo Pezzini. As you can guess, I'm Italian, and I'm calling you from Rome. So welcome, everybody, from the Eternal City. Yeah, a lot of you probably never heard of Digital Integration Hub, but for sure you know about APIs. right? APIs is indeed emerged as a ubiquitous business enabler. To give you just a little bit of a flavor, a couple of years ago in 2020, McKinsey ran a banking survey, and what they discovered was that banks were planning to double, and in some cases even triple, the number of APIs they will deploy by 2025. And they are not doing this for fun. They are doing this because they want to meet certain business goals, including reducing IT complexity, improve business agility, support partners. They need to meet certain compliance regulations, such as open banking in many countries. But probably most importantly, because they want to use APIs as a vehicle for innovation in terms of products and services and so on. So APIs are critical from a business point of view. But often when organizations, they design and deploy the API environment, they forget about some non-trivial issues such as scalability and latency and throughput and availability and agility for change. And the bad news is that if you deploy an API architecture without taking proper account, without taking into proper account those challenges, there is a risk of catastrophic business failure looming large on you. A good example I have is Coinbase. Coinbase is, as you know, is a cryptocurrency company, and they spent about $14 million to run a short and even controversial commercial during the last Super Bowl. The commercial was very successful. They had 20 million hits on their website in 1 minute, and the server crashed miserably, right? Those are the kind of failures you may incur if you don't pay attention to scalability, latency, throughput, availability when you design your API environment. And in the rest of the presentation, I'm going to discuss with you how a DIH architecture can really help addressing those challenges and can be used also for other interesting scenarios. So the presentation is split in 3 parts. Basically, in the first part, I'm going to discuss with you what a digital integration hub actually is and how it can help sorting out the API challenges we were mentioning earlier. In the second part of the presentation, we are going to explore in a little more details what is the business value of DIH, which goes above and beyond improving scalability and performance of your API environment. And in the last part of the presentation, we're going to discuss a little bit what are the key enabling technologies to build a DIH architecture. So let's start with the first part of the presentation, what the digital integration hub is and how it can help from an API perspective. So I will guess that many of you have implemented and are running an architecture like this in your organization, in your enterprise. So you built a whole bunch of digital applications, mobile applications, web applications, social application, what have you. And those applications, they needed to deal with data and which are basically held by your system of record applications and databases. For example, if you are a bank, your mobile banking application needs to connect back into your core banking application system. If you are a university or a college, your web applications, web portals for students needs to be connected back into a whole bunch of different student information systems, training system, etc. So the way in which this problem has been solved is by basically layering an API set of capabilities in front of the system of record applications. This API layer basically provides application programming interfaces, typically in the form of REST APIs or web services API in some cases, which the digital application at the front can use in order to consume the data stored in the system of record. And in between the front-end API services layer and the system of record, there is a integration layer, typically implemented through an enterprise service bus or an integration platform as a service, etc., basically connecting the services implementing the API capabilities with the system of record at the back end. Now, this is a well-known, well-understood architecture that a lot of you probably have implemented over the years. It is an architecture which is well-known and proven. basically it dates back 25 years when organizations were beginning to experiment with service-oriented architecture, right? Of course, technology changed in the meanwhile. You know, the first implementations of SOA, which I saw in the past, were based on Corba and object distributed computing. Now we use a completely different set of technology, but the principles, the architectural principles, are basically the same. This API-based architecture is supported by mature and popular platforms and tools, such as API gateways, API management platforms, enterprise service buses, ESBs, integration platform as a service, etc. Of course, a growing number of business application and software as a service application, they natively expose APIs, which makes the implementation of the architecture much more easier. And this model is fully supported by integration vendors, API management vendors, and so on. However, that architecture has some drawbacks. The most important ones are listed here. First and foremost, if you expose your system of record applications to digital channels, you can generate a lot of additional workload on your system of record application. Workloads that maybe your SORs are not really able to support, or they can support this additional workload by scaling up your system of record application. An episode I can share with you is a consumer electronic company in Europe, which built a B2B portal to deal with their resellers, dealers, etc. And of course, this B2B portal was integrated with their backend ERP system to provide up-to-date product availability, product prices, product descriptions, etc., to enter orders into the ERP system through the portal and so on and so forth. Well, at some point, this B2B portal was generating on their backend SAP ERP system more workload than the rest of the enterprise. Right? So theoretically, in order to support this B2B traffic, if you wish, the company had to double the size of their SAP environment in terms of hardware and storage and etc. Another problem is that the architecture, the conventional, if you wish, architecture is that it is very hard to implement a 24-hour-by-7 continuous availability, full function business operation. For example, if you have a number of system of record application at the back, chances are that one or multiple of them cannot be available 24-hour-by-7. They have to be shut down to run, batch processes and recoveries and things like that. Connecting the front-end layer, the API layer with the back-end system can be very complicated. For example, I can mention a CPG company which had information about their customers spread across up to 40 different ERP systems. So you can imagine how complicated would that be to create an API collecting customer data from 40 different ERP systems, right? So those are the drawbacks and the challenges associated with the traditional, if you want, conventional architecture. So 5 or 6 years ago, when I started doing research on the DIH concept, at the time it didn't have a name. It was named DIH after 2 or 3 years. But when I started doing research on this topic, I observed a pattern which was at that point in time emerging, which then was named DIH. So what is a DIH and how different it is from the conventional API architecture? Well, there are some things which are the same. We have the digital applications, mobile, web, whatever. You have the system of record applications, of course, and we have an API layer decoupling the front-end channels from the back-end. But the number one big difference is that the API layer, the services supporting and implementing the API themselves, don't connect back into the system of record. They find the data they need in this intermediate data management layer. So fundamentally, this data management layer stores a replica, a partial and consolidated replica of the data managed by the system of record, right? Therefore, there is another conceptual difference between the conventional architecture and this one, that the integration layer, which sits in between the data management layer and the system of record, has a different responsibility. It's not about connecting the API layer with the system of record, but it is about making sure that the system of record and the data management layer are constantly and in sync in real time or near real time. So in other words, if there is a piece of data that changes in the system of record, this piece of data must be replicated in real time into the data management layer. If, for example, Massimo address is changed in your backend ERP system, this piece of information must be replicated into the data management layer. So at any point in time, the data in the data management layer and in the system of record are in sync, are the same, with maybe a little bit of latency. So another interesting variant, if you want, is the following. Usually organizations, they build the DIH because they want to provide high performance, highly scalable APIs. Maybe they want to offload their system of record from API workload. But once the data are in the data management layer, I have seen organizations leveraging those data for analytics. I'm not advocating here that DIH is an alternative to data lakes and data warehouses, this kind of architecture. Far from me to say that. Those are architecture which are designed to support analytics. But again, once the data are in the DIH, why not using them for certain analytical applications, which make sense to implement because they use exactly the same data. The example I have is a mid-size insurance company which built a DIH to provide a single view of customer data through mobile application for their brokers and agents to the customers, etc. Right? But then they realized one thing, that in the DIH, they had all the data about their customer, all the history of their relationship with the customers, including what kind of policies they sent them, what kind of products and services, and their history in terms of claims. So they realized that they could use those data to implement a fraud detection application, which is a very typically analytical application, right? So the DIH is there, it supports the classic mobile web applications, etc., but it is also used to run this particular fraud detection application. So there is a business opportunity that you can leverage by plugging analytical capabilities in as part of your DIH. Right? So what are the benefits of such an architecture? Well, greater scalability, performance, and throughput. The scalability, performance, and throughput of the API layer doesn't depend on the scalability of the system of record. It depends on the scalability of this intermediate data management layer. You can scale it up and down as much as you want by adding servers, by triggering virtual machines, what have you. You can design this layer for scalability, and often the system of record is not designed for scalability. It enables full function 24/7 operations. Basically, if one or more of the system of record are not available for some reason, the overall system can keep working because the API layer, the digital application, they find the data they need in the intermediate data management layer. Of course, there will be some reconciliation and resynchronization of data when the SOR are back, but in principle, the system can work 24/7. This architecture protects the system of record from excessive workloads. So you don't need to buy more hardware to support the digital applications. You can design the data model within the data management layer in an optimal way to support, for example, super fast API delivery. And it reduces complexity from an integration perspective, because fundamentally, the only thing that the system of record they need to do is to, by using typically an event-based architecture, could be change data capture, could be Kafka, could be message-oriented middleware, doesn't matter. The system of record has to notify the DIH layer when there is a change in the data. Of course, it would be naive for me to say that is all good. There are some drawbacks and issues. We have data management challenges. We have to design yet another database and data store and design it for scalability and performance, availability, etc. So we need to address those challenges. We are creating yet another copy of the data, right? And that's a fact of life. So we have to deal with data governance issues. Typically, as we are going to see at the end of the presentation, a DIH consists of many different technology components that need to be aggregated and managed together. And the other problem is that this is a pattern which is kind of unfamiliar for many organizations, especially mainstream organizations. And therefore, there is you don't know how to build it. Fundamentally, you have to learn how to build it. And unfortunately, there is also limited experience in terms of system integrators and service providers, right? So those are the main challenges when it comes to implementing a DIH. So when it makes sense to consider a DIH. What is the business value, fundamentally, of a DIH?
So, Massimo,
Go ahead.
Sorry to interrupt, but we already have a question about this part.
Go ahead, Noam.
Let's go ahead and take it. Question from Usman. Hi, Massimo. The challenge with the data management layer is the data quality. How to manage this?
We will probably need to spend the rest of the webinar to discuss this. As I said, it is a challenge, right? We are creating yet another copy of the data, so we have data quality, we have, data lineage, kind of issues, etc. You manage in exactly the same way in which you manage data quality and these kind of things in a regular environment, let me say. You may have noticed that in the data management layer, there are two components. One is the data store itself, and the other one is called metadata management. Basically, the metadata management layer is there exactly to support this type of requirements: data quality, data governance, etc., etc. We're going to spend a little time later on to discuss this. Any other question, Noam?
No, not at this time. Please go on.
Okay, thank you. So what is the business value of a DIH? When should the organization consider a DIH? Well, fundamentally, anytime an organization is embarking in API-driven digital transformation initiative, at least they should spend a little time looking into the DIH and figure out whether it makes sense for them or not to implement such an architecture. We spoke about performance, throughput, scalability, and 24/7 online operations, right? So if you are designing a digital transformation initiative, which you are going to expose to large populations of users, which require performance, scalability, and so on, at least evaluating whether the DIH is useful or not, it is something that you should consider. There is a second aspect, which is the single view of something, data defragmentation. In some cases, I have seen organizations implementing DIH, not because they have performance or scalability kind of issues, but because they had a very fragmented data landscape. For example, I was mentioning earlier this CPG company, which had customer data across up to 40 different ERP systems. So in a situation like that, where you have very fragmented data scenarios, it makes sense to consolidate those data into a single place to support the API and digital layer. This is, for example, quite common in insurance, I have seen. For historical reasons, insurance company, they have an IT environment which is very much siloed by product line. So they have a, healthcare insurance system, a property and casualty system, a life system, et cetera, and then they have the claim system, right? So nowhere in an insurance company there is a single view of the customer, typically. So I have seen quite a number of insurance companies, not necessarily big insurance company, maybe even mid-sized regional insurance companies, implementing a DIH exactly because they wanted to have in one single place all the information, all the data about their customers. In some cases, I have seen organizations leveraging the DIH to offload their system of record. This is a classic example in banking or in travel and transportation industry, where still a good chunk of their system of record is running on big IBM mainframe, very expensive. And therefore, they are using the DIH to eliminate some of the workload hitting the system of record, some of the workload coming from the internet banking application, online reservation systems, etc., into the DIH, right? So offloading the system of record is another scenario where I have seen people using the DIH. And as we are going to see later on, organizations are looking at DIH also to support their application modernization initiatives, a corollary of which could be cloud migration. And I'm going to spend a few minutes on this topic later on in the presentation. So those are the reasons why organizations most of the time they look at DIH. But as I was saying earlier, there is complementary business value that you can gather from a DIH by plugging in analytical applications as well. And there are other opportunities linked to the architectural decoupling, which is implicit in a DIH architecture. If you think about for a second, in a DIH environment, the front-end layer, the APIs and the digital applications, and the back-end layer, the system of record, are completely decoupled. They don't even know about each other. The mobile application don't need to know what kind of back-end core banking application you have. It doesn't know, and it doesn't need to know, because all the data are in the data management layer, in the DIH itself, right? So this architectural decoupling is an enabler for modernization and migration, but it is also a way to optimize skills, for example, right? You don't need to have universal developers who understand both the system of record environment and the digital environment. You can have the digital developers focusing on building mobile apps, portals, etc., and you have the system of record developers, which are focused only on emitting events which feed the digital integration hub. So the conclusion is that it makes a lot of sense for organizations to consider a DIH because it's a very versatile architecture that can support a number of requirements, as you can see here. And some of those requirements can be very tactical. For example, offloading the mainframe. So it's a tactical requirement, but it can support also strategic business goals such as digital transformation or application modernization. A good example of this is Société Générale, which, as you know, is a French financial services institution. And this is, they are using a DIH for their global trading operations. So what was the problem? The problem was providing a unified data service to support the bank's global investment banking operations. From a business value perspective, they wanted to enable around-the-clock global trading and investment processing across 3 continents, because the Société Générale investment banking operation are based in Paris, New York, and Hong Kong. So they wanted to be able to, perform trading around the clock across these 3 geographies. So they put together an architecture, which you see schematized here in this diagram. They have a bunch of system of record applications in Paris, which they feed a DIH, which is implemented using the Gigaspaces technology. And the DIH, the central DIH implemented in Paris, is replicated in Hong Kong and New York in near real time. So basically, at every moment in time, the data in Paris, Hong Kong, and New York are the same, eventually. So what are the results? They have federated 9 system of record applications, some of them very old, based on legacy technologies, etc., which are feeding the digital integration hub. They have 300 plus front-end applications which consume the data in the DIH. And these applications are used by in excess of 10,000 users every day, both internal to Société Générale and external. 10,000 users is not a huge amount of users, but they generate a lot of workload. I don't remember by heart the number of transactions on a daily basis, but I believe it's something like 100 million or something like that. So not a lot of users, but generating a lot of traffic into the DIH. So the lesson learned. they use any memory architecture, the gigaspaces architecture, because it was imperative for them to provide low latency data access. You know, we are talking about trading, and you know better than me that in financial trading operations, you know, milliseconds count. You know, the difference between making a lot of money or losing a lot of money is in sometimes a few milliseconds, right? So in-memory architecture was needed for that reason. They also leverage another feature of gigaspaces, which is this asynchronous replication technology, which makes it possible to replicate in a transparent way from the point of view of the application, the data from Paris to Hong Kong and New York. So this is a feature of the platform. Société Générale didn't need to write any code to support this thing. The API was designed centrally by the Parisian office, by the Parisian DIH, Center of Excellence. And a problem they had to face was that these different system of records are so different from each other that they needed to deploy quite a number of different integration technologies to really synchronize the data from the system of record into the gigaspaces platform. Very successful implementation. It has been around for a number of years. I think they started something like 8 years ago implementing this architecture, and they keep evolving in terms of changing the underpinnings of the technology, taking advantage of the most recent evolution of the platform, and also in terms of adding new front-end applications and new data. Now, as I was saying earlier, the DIH is a versatile platform, right? Once you have it in place, a number of ideas on how to use the data in the DIH come to mind. You know, as we were saying earlier, most organizations, they implemented DIH because they have these scalability, performance, availability problems in their API layer. But once you have the data in the database, you can use different methods, if you wish, to access to those data. For example, you can trigger queries to those data. So that's how you use the data in the DIH to support analytical application. For example, the fraud detection system I was mentioning earlier in this insurance company. This is not necessarily possible every time, but this is a feature, for example, of the gigaspaces technology and other technologies, similar technologies. You can generate business events out of the DIH. So in other words, if there is a change in a particularly important piece of data, this information can be propagated in a push way to the consumer applications. And last but not least, of course, once you have the data in the data store, you can extract them using batch, managed file transfer, or other forms of push or batch push methodology, right? And a good example of a company which is leveraging this type of capability is a major North American utility company, pretty big one, operating across the continent. And the problem they had was the following. They wanted to have in one place, in a single place, a consolidated view of their employee data. Practically speaking, it is very important for them to know where an employee is, whether he is available or not, and what are the skills he has, right? So those are employees which are needed to, I don't know, fix problems in the distribution network, or to you know, deploy yet another customer, etc. So of course they have very specific, very specialized skills, and it is very important for the company to know exactly where these skills are and whether they are available or not, right? And if I remember correctly, I could be wrong, but the number of employees they need to track from that perspective is something like 10,000. This is, in any case, the order of magnitude. The problem is that those employee data are available, but are scattered across 3 different applications, in part on cloud and part on premises. So basically, the business value they needed is single source of truth for employee and worker data. So they put it together an architecture like this one. As you can see, the system of record are 3 different applications. In Workday, they have data about their employees. In Fieldglass, they have data about temporary workers. And in a custom Oracle application, they have data about contractors, fundamentally. So by using an integration platform, in their case, the Workato integration platform, they extract the data in real time, in near real time data from these 3 different systems. They package those data into a consolidated format, and this data is stored in Oracle. And then different downstream application, they can collect those data, can have access to those data using a variety of different methods. In some cases, the downstream application, they use REST APIs. In some cases, they use web services. In some cases, they use a managed file transfer technology, right? So the result is that last time I spoke with them, which was probably, I don't know, 6 months ago, something like that, they had between 15 and 20 downstream application that can consume those data from the employee data hub, which is more than they initially expected. And the interesting thing is that the downstream application teams, they have implemented integration flows which are needed to them in a self-service fashion, right? So central IT, HR IT is not involved in helping the downstream application developers to get access to the data. The lesson learned: so service integration facilitates adoption. In other words, they are using a technology which is easy to learn, and therefore, the downstream application developers could easily design the integration flows needed to download the data from the DIH. The fact that DIH supports different and multiple data access models was a requirement, because the downstream application, they have differentiated requirements and needs. And they even though the downstream application teams are autonomous, they can do whatever they want. Nonetheless, the central support, especially for the platform, the integration platform, which is used by the downstream teams to implement the downloading processes, was required to really empower the downstream application teams. I alluded earlier that the DIH can be a very useful enabler for application modernization. This is a trajectory, this is a path which I have seen a few times. So what happens is you have your legacy system of record application running on mainframes, AS400s, all the Unix boxes, whatever, and you want to modernize. You want to replace them with software as a service or with brand new custom applications, whatever it is. But at the same time, you want to move forward with your digital initiatives. So the idea is that you use the DIH to decouple the front-end layer, the digital layer, the digital environment from the system of record, and you start building a bunch of APIs and maybe a few digital applications. At the same time, you maybe replace one of your system of records, right? You, for example, replace an aging ERP system with a modern cloud ERP system. But this has no impact whatsoever on your digital environment, right? The digital environment, the only thing it says is the DIH. Right? The only thing you need to do is to make sure that the new ERP system, in my example, cloud ERP system, is able to feed data into the DIH. So while you modernize your system of record, you build new APIs, you build new digital application, and at some point you completely decommission your legacy system of record applications, and you have a fully modernized backend environment, and while you can keep extending your digital environment, right? Of course, this is a long-term process. It may take 2 years, 3 years, 5 years. So, but the DIH enables you to actually evolve the digital environment and the system of record environment according to the different speeds, if you want. It's going to take 3-5 years to fully modernize your system of record, but you are going to add new APIs and new digital application every week, or maybe every month, right? So the two layers, they evolve at different speed, different velocities, and the DIH makes sure that the two environments are completely decoupled. So a DIH enables a stepwise, minimal disruptive, bimodal modernization approach. And bimodal, I mean these two speeds IT type of approach. A corollary of this scenario is cloud migration. Once again, you have your digital environment, right, that you build, and you have the DIH, which decouples the front end with the back end. And you start migrating some of those applications to the cloud. So for example, you migrate, as in the previous example, you migrate your legacy on-premises ERP to the cloud. Maybe at the same time, you also migrate some of the APIs to the cloud. So what you need is a double DIH. One DIH supporting the APIs on premises and a different DIH supporting the API in the cloud. But the two DIH system can be synchronized so that they have exactly the same version of truth across cloud and on-premises environment. This is the same architecture, the same technology that, for example, Société Générale has used for different purposes. So you keep on going, and at some point you have your entire set of system of record applications in the cloud. You have your entire digital integration hub in the cloud. You have your entire set of APIs in the cloud. So a DIH provides an incremental, minimal disruptive cloud migration support. So let's dive into. Yep, go ahead.
Take another question.
Yep, go ahead.
Actually, it relates. It came right before the last slide, so you may have answered it. But just to be on the safe side, Chandra is asking, with our organization moving towards building industry standard MDM and analytics platforms, how do you see we articulate the DIH value proposition considering our data resides on-prem and in cloud?
Yes, as I said, the value prop is one of the 4 or 5 items I was describing earlier. Do you want to build a highly scalable, high performance, low latency API layer? You should consider it a DIH. Do you need to have a single view of customers, suppliers, students, patients, citizens, what have you? DIH makes sense to be evaluated. For example, you said the customer, sorry, I can't remember his name, or her name, but the customer said we have data all over the place on-prem in the cloud. Well, you consolidate all the data that you need to support your API layer in a DIH. The other comment is you can consider the DIH also if you wanted to offload your system of record applications. I mentioned mainframes, but maybe you want to offload your software as a service applications. Some software as a service applications are very expensive if you hit their API layer very frequently, right? So for example, I have seen some customers using DIH basically to reduce the amount of APIs calls hitting their software as a service application. And last but not least, as I was saying, a DIH makes sense when it comes to modernizing your application environment. Any other question, Noam?
Let's move on, and we can take more questions
at the end, of course. Yeah. So we are at the end of the session. I have a few slides to discuss the technology landscape. Well, by now we are very familiar with this picture, and if you look at the technologies which are needed in order to implement this architecture, you'll find that we have many different moving parts. We need an API gateway, because if you expose APIs, of course, we need to protect them from a security perspective, from a monitoring and management, etc. perspective. So we need an API gateway. We need a microservices infrastructure, Docker, Kubernetes, whatever it is. So an environment on top of which you can build and run the services implementing the API functionality. You need an integration platform, an event-based integration platform to synchronize the system of record with the DIH environment. As I was saying earlier, you need some sort of metadata management solution to help you support from a data governance, data quality, data stewardship, etc. point of view. You may or may not need to have some analytics and BI tools if you want to add value from an analytics perspective. And of course, you have to select very carefully the data store platform. So what kind of technology do you use in order to store data coming from the system of record, right? We don't have time to explore all these different bits and pieces, but we are going to focus on 3 things: the data store platform, and the API gateway and integration platforms. So let's explore this data management layer, right? What is it? Well, it is essentially a data platform which holds a consolidated copy of the backend data. Not all the data, but only the data which are needed in order to support the API digital layer. So it provides a single view of customers, products, prices, itineraries, students, patients, citizens, you name it. It is by design synchronized with one or multiple system of record application and data sources, typically using event-based technologies such as change data capture, message-oriented middleware, event streaming platform, etc. It is typically designed for low latency, scale out, and high availability. And as I said, we need this metadata management capability to support data governance, data quality, and so on. So what are the enablers? Sincerely, in my analysis, in my discussion with clients, I've seen a little bit of everything. For example, the energy utility company I was mentioning earlier, the North American one, they use a classic relational database management system, Oracle in their case. I have seen organizations using in-memory database management system and in-memory data grid technologies such as Gigaspaces and others. I've seen people using NoSQL database management systems. Typically, the trade-off is between latency, throughput, performance, and amount of data that you need to store, right? So if the amount of data you need to store is very large, you probably need a NoSQL database management system. If performance, scalability, latency is your main concern, you probably need an in-memory technology. And when you have both requirements, maybe you need to combine the two technologies, right? But my observation is that when the problem is really high performance, high throughput, low latency, highly scalable architecture, in-memory computing technologies is to be preferred. The example I can mention here is, again, a utility company, this time in Europe. They put together a whole bunch of mobile and web application for helping their customers self-service themselves. You know, those applications allow the customer to, pay their bills, check their consumption rating, et cetera, right? The classic self-service application for customers. And those mobile and web applications were connected through an API layer with their backend ERP and billing system. And those applications were a failure simply because the system of record could not cope with the workload. So basically, most of the time, these applications will time out and will not provide back the data required. Of course, this was a bad thing from a customer satisfaction point of view. So what this energy utility company did was to layer an in-memory architecture, to build a DIH based on in-memory architecture, so that they could provide the performance and the scalability and the latency required by the application. And now those applications are very successful. The other components which I wanted to spend a little time on are the integration layer and the API gateway layer. Why do we need that? Well, why do we need those rather? Because we want to enforce API policies from a security perspective, accessibility perspective, etc. As we said, we need to keep the data management layer and the system of record in sync. And this can be a complex problem because maybe we have multiple system of records, so we need to use different technologies to synchronize them all with the DIH. For example, this was a problem for Société Générale. I think they used 3 different integration technologies to plug their system of record into the DIH architecture. And it can even become more complicated if you want to implement bidirectional synchronization. So not only making sure that the system of record updates the DIH, but also vice versa, that the DIH synchronizes back with the system of record, which is an uncommon pattern, but I have seen some examples of this being implemented. So what are the technologies that people typically deploy? I have seen, again, a little bit of everything. Integration platform as a service technologies. You remember the utility, North American utility example. API gateways, of course. data integration tools like ETL tools, change data capture technology, event brokers, message-oriented middleware, and enterprise service buses. As I said, most likely you need to adopt a combination of integration technologies if you have a very complex system of record landscape. Maybe one is not sufficient. So, putting together a DIH, therefore, may require you to combine multiple products, possibly from different vendors, and make them work together, secure, monitor, manage them all, etc., which is not a trivial task. Thanks God, however, there are in the market a growing number of, you may call them out-of-the-box digital integration hub products. So products which provide you with all the component parts that are needed in a single platform. And of course, the GigaSpaces Smart DIH is one of them. Right? So you have two options. Build your own DIH architecture by combining multiple pieces from different vendors, or buy one of these out-of-the-box solutions. I will say that out-of-the-box solutions, I have expectation that these out-of-the-box solutions will be widely adopted by the market because they reduce the barrier to entry, right? Not many organizations in this world, they have the skills and resources to really put together a DIH by themselves, combining open source and closed source products and making them work together, et cetera, et cetera. Whereas, so basically so far DIH has been adopted primarily by large organizations. But now, through these out-of-the-box solutions, even mid-sized organizations, which they don't have the skills, they don't have the resources to aggregate their own DIH, can leverage the benefits of DIH by buying one of these out-of-the-box products. So these products are, if you want, reducing the barrier to entering and making DIH affordable also by mid-sized organizations. So what are the benefits and drawbacks of these two approaches? Well, in a do-it-yourself environment, you build your own one. You have more options. You can mix and match closed and open source building blocks, but you have no single vendor lock-in. However, the time to value is longer. You need advanced skills, and the outcome is a complex to monitor, manage, secure, and administer environment. The benefits of those out-of-the-box solutions, of course, the time to value is in principle shorter because basically you deploy a product. And in many cases, this product is in the cloud, so you not even need to deploy it. You don't need super sophisticated skills. And given that it comes from a single vendor, the expectation is that it is much easier to monitor, manage, secure, and administer. Of course, there are also drawbacks and cons. Of course, they are a take it or leave it solution, right? Either you like what the vendor provides you, or you leave it, in the sense that you cannot replace, the database or the microservices environment provided by the vendor. It is what it is. As I said, the number of vendors providing this type of out-of-the-box capability is growing, but there are not very many options. Let's say probably between 5 and 10 in the market. And of course, the problem is that given that there are different areas of applicability of a DIH, not necessarily the one product that you buy fits with all your requirements. So what are the final recommendations? Take DIH seriously. Consider a DIH architecture if you want to provide responsive, low latency, 24/7 APIs. If you want to protect system of record from excessive low value workloads. There is a great example, which is Leumi Bank, which is the second largest bank in Israel, I believe. And they have implemented the GigaSpaces technology to offload their mainframe environment successfully. So this is a use case. If you want to maintain an up-to-date consolidated view of fast-changing data, if you want to enable digital front-end to access system of record applications in multiple ways, for example, the energy utility company I was mentioning earlier, and if you want to benefit from this drastic decoupling of the front-end digital environment from the system of record to support, for example, application modernization or skill optimization and so on. What are the watch-outs? Well, first of all, you have to think about whether you're adopting it in a strategic or tactical way. Mainframe offloading could be tactical or it could be strategic. And this is a decision you have to take in order to have a balance of investments and benefits. You have to keep in mind that some assembly work may still be required, even if you adopt an out-of-the-box solution. For sure, there is this last mile connectivity between the system of record and the DIH, which can be quite complicated and might require you to write some code and do some stuff. The out-of-the-box products are available, but emerging, and there are not that many, as I said. And we need to take into consideration data governance, data quality, etc. So metadata, data management is important. And the other thing is that, unfortunately, this is a temporary problem, of course, but unfortunately, skill and industry experience are still limited. So you need to secure this type of skills, and most likely they are expensive. With that, I think I'm done. I said everything I wanted to say. Thank you very much for your time. And Noam, do we have other questions that we can try to answer in the remaining 5-6 minutes?
Yes, we do. And I think we have time to take 2 or 3 questions.
Yep.
So we'll do what we can. Let's see. So there is a question that relates to the topic of do-it-yourself versus kind of out of the box. And the question is, you mentioned the consumption of data from DIH could be real-time events, batch, etc. Does DIH have the components for consumption, or is it external, e.g., using Kafka for events, data integration tools for files, etc.?
Well, typically the DIH, out-of-the-box DIH, they provide enablers for that, right? So they provide an API environment, an event environment, etc. But then the way you propagate events, for example, it's up to you. You can use Kafka, you can use something else, right? So the DIH itself doesn't necessarily provide and manage file transfer, but it enables those capabilities by providing hooks fundamentally that you can use to connect into that.
Thank you, Massimo. Let's take another question. Considering DIH architecture, the core is focused on low latency and high performance data store, are there any learnings on the data hub technologies themselves? Our use case is low volume, but large data size payloads.
Yeah. Well, this seems to me probably I should speak with Ramchandra to better understand, but this seems to me a scenario where most likely you need some sort of NoSQL database environment, Mongo, Cassandra, one of these things. Maybe complemented by any memory technology for those few use cases which, or maybe not so few use cases which they do require high performance and highly scalable. So this is something that I have seen, right? In very complex scenarios, maybe use an in-memory architecture to store the hot data, right? And in the back, you have a NoSQL database to store the warm and cold data. So a combination of technologies is sometimes it happens. For example, Société Générale used to have the Gigaspaces layer and an Oracle layer, and now I think they are getting rid of Oracle and replacing it with some Gigaspaces technology for that.
Great, thank you, Massimo. And we have time for one final question before we are up. And here's an interesting question. What are the approximate cost of implementing an out-of-the-box DIH? And how do you measure the ROI on this investment?
Well, the cost of the out-of-the-box DIH implementation, all considered, this is a question for you, Noam, in the reality, but in my experience, you can start from maybe a few hundreds of thousands of dollars, maybe $100,000, $150,000 to $200,000 And you can spend millions of dollars, of course, if your DIH is very complicated. Return on investment, as I said, it depends on what is the business goal, right? For a very simple way of calculating return on investment is to measure how much you are offloading from your system of record. So in the probably Noam, I don't know, but in the Lumi case, the Lumi Bank case, the offloading the mainframe was an element of the return on investment, right? But if your goal is not necessarily offloading the system of record, it is to enable APIs, enable digital channel, enable a new e-commerce application, what have you, then the return on investment is calculated on the end-to-end process, not just on the DIH itself.
Great. Thank you so much, Massimo. And we are at the end of the hour. So thanks, everyone, for joining us today. I hope this was interesting and beneficial. And as I mentioned before, we will make the recording of this session available for you guys if you're interested in that. And hopefully we'll see you again in a future GigaSpaces webinar. So thanks again, and enjoy the rest of your day.